Hello, everyone. My name is Etienne Espagne. I'm a senior economist at the French Agency of Development in the research department. And I'm pleased to welcome today a very special topic on the evaluation of the economic impact of typhoons in Vietnam using satellite data. With the co-authors Boi-Yen, who is studying at the Paris School of Economics, Kenneth Houngbedji from the Institute of Research and Development, and also Professor Goduktein from the University of Science and Technology in Hanoi. Before I leave the floor to Yen for her presentation, let me just give you a few elements in the way you could use this Livestorm platform for a more interactive conversation. On the right-hand side of your screen, you should have chat or questions, so don't hesitate to ask questions throughout the presentation, and I'll do my best to translate them, and we will do our best to address them after the presentation. You also have the chat if you need some more immediate remarks and comments. So Yen, I guess you can upload your slides, and the floor is yours.
Okay, thank you, Etienne. Hello, everyone. Thank you for being here today. I would also like to thank my co-authors and the AFD for making this happen. So let's start the presentation. Today, I would like to present the macroeconomic impact of typhoons on Vietnam economic activities using nighttime light data. So we would go through the context and motivation, what relevant research has found, and our methodology, data, and results. So why typhoons? It is one of the most destructive natural phenomena. From 1992 to 2020 in Southeast Asia alone, the International Disaster Database has reported more than 175,000 deaths. 5 million people are made homeless, and the estimated damage of more than $40 billion. So this phenomenon has many names and classification. To sum up, is based on two aspects: where it starts and how strong it is. So for storms starting in the Atlantic Ocean around America, it is called hurricane, while on this side of the Pacific Ocean, next to Asia, it is called typhoon. And hurricanes and typhoons are further classified based on their strength. Below 116 kilometers per hour, it is classified as a tropical storm or depression. And above which you have a typhoon and hurricane of category 1 to 5. But regardless of where it starts and how strong they get, they all have the same mechanism. So the whole system is fueled by warm ocean water. It rotates around an eye, and in this eye, the weather is calm and clear. But at the eye wall, there's the heaviest rain and the strongest wind. So that's why their official name, scientific name, is tropical cyclone. So when a typhoon hits land, most of the damage happens due to the eye wall. So first you have very strong wind that can cause injury, death, destroy power line, houses, and crops. But it is not yet the most destructive aspect. On top of this, you have very heavy rain. This can lead to floodings that last for an extended period of time, and even after the storm has passed. It can also trigger landslides in mountainous areas. People's lives are disruptive. It threatens access to clean water and wildlife habitats. And yet, the most destructive aspect of typhoons is storm surge. Ocean water would rise very high and push inland with great speeds, and it can travel to great distance. Coastal land is lost, and salt water with toxic substance can infiltrate the soil, groundwater, and destroy the ecosystem. So the bad news is it doesn't stop there. There are social and economic consequences after typhoons has passed. Take a look at the case of Typhoon Haiyan, Many countries in Southeast Asia were affected, thousands of deaths, millions were made homeless, and some areas were uninhabitable for months. Hospitals and schools are destroyed. There were also violence and looting reported. So what does the future have for us? Scientists have been producing future projection of tropical cyclones under different scenarios. There is still much uncertainty about this natural disaster, and the projected change are very different among different regions. And even within a region, there's still large variance in findings. For example, Ying et al. Finds that the frequency can change by 70% less to 60% more. Average intensity can go from 3% less to 18% more. But rainfall is increased overall. And a paper by one of our co-authors finds that under RCP 4.5 and 8.5, we have a decrease in both average intensity and frequency. These different results come from the different models and their climate change input. However, according to the IPCC, it is agreed that there will be more likely than not to have more intense typhoon with heavier rainfalls, and they can last way longer. Future impact of typhoons also depends greatly on the changes of social and economic variables. Recent research has pointed out that the increase of damage from typhoons comes largely from economic development. A larger population means more people exposed and vulnerable. Recent studies have shown that there is a very high population concentrated along or 100 kilometers near the coast, where they are most vulnerable to typhoons. And in Asia, that's 60% of the population. With sea level rise causing more coastal inundation, storm surge, and floodings can be more severe. That means food security, livelihoods are at risk, and poverty is exacerbated. And we believe Vietnam is a very crucial case study. According to the World Bank and the IPCC, the country is among the most vulnerable nations to climate change. This vulnerability comes from two factors: a diverse geography and its economic and social situation. Vietnam locates next to the most active typhoon ocean basin in the earth, and it is not an isolated incident. It is very frequent in Vietnam. On average, there are 5 to 6 typhoons per year, and at the same time, the country has a very long coastline, making it prone to saline intrusion, long range of mountain nearby, so you have trigger landslides when there are rainfall, when typhoon hits land, and many low elevated regions that are subjected to heavy floodings. And this is home to the majority of the population. So in addition, the country is developing fast, but under-equipped. Natural disaster impact is not equal among different social classes. Informal workers without protection and the poor lacking the financial ability to cope are the most vulnerable. So in Vietnam, in 2018, there are still more than 1.9 million people living under $1.9 a day. And the majority of the labor population is in the informal sector and in agriculture. This poses many adaptation challenges. So there have been efforts looking at the impact of natural disasters in Vietnam. They look at household welfare and aggregate statistics. They measure how much the reported damage and deaths affect the economy, or if a household during the last 3 years have experienced a typhoon, how it will affect their welfare. So some use the meteorological data at 11-kilometer resolution as well. However, there are limitations to these studies. Evidence have pointed that the impact of extreme events are very localized and it does not last for over a year. So if you try to measure how it affects a family during the last 3 years, they have experienced typhoon, why there can be many typhoons per year, so the conclusion cannot be very accurate. And if you look at the statistics of the whole country, the effect can be diluted and lost. And frequently used data is the International Disaster Database, MDAT. They only report an event if damage exceeds a certain number. A paper has found that the richer the country is, the events happening there are more likely to be reported. So as for Vietnam, with the humble economic level, a lot of events are not reported. And finally, some paper relies on meteorological data and estimated the strength of the typhoon from models. We examined these models and found that they are not accurate when applied to Vietnam. To sum up the findings, generally, researchers found a negative effects of typhoon on income, consumption of families. Lower output growth and infrastructural damage leads to a short-run boost due to a reconstruction effort. Similar studies have also been done all around the world, and they have similar limitations. With the advancement of technology, satellite data has managed to capture human activities at great details. Among these data, nighttime light has been adopted to investigate human economic activities, and it is especially useful in natural impact studies. So this is a perfect example showing the drastic difference in economic development between South and North Korea. It gives us a glimpse into what is happening in the most secretive area of the world. It also provides information at 1 kilometer resolution, and it is an objective measure. In addition, this study also used wind field model. It is a parametrical tool that gives you an approximation of the wind speed in a location produced by the storm. So we replicated these calculation of relevant studies and compare with the weather station data in Vietnam. And here's the result. We see that for an observed wind speed from the weather station data when it is affected by a storm, the model also gives us an approximation. And when the station sees zero wind, the model gives wind speed of 0 to 20 meters per second. So we also tried different models, and this mismatch comes from the fact that these models don't take into account geography. Wind can flow very different when you are in an empty field or next to many high-rise buildings. For this reason, we don't think it can be accurately applied to the case of Vietnam due to its diverse geography. So nevertheless, in general, they found a negative impact of typhoon to economic activities. And globally, it is 0.3% reduction of, on average, every year of nighttime light. And all countries suffer very different losses from typhoon. It depends on the pattern and the frequency of these disasters and the level of economic development of each country, how they cope and mitigate. We want to use nighttime light data to proxy for economic activities of Vietnam and benefit from its great detail spatially and temporally. And instead of wind field model, we use the wind radius. This information is provided by the Regional Meteorological Agency. It is collected through satellite imagery and surface observations. It is vital to determine which areas are impacted by typhoons. And it is widely used in climate science as the best estimate of the true values to understand the structure of typhoon. And with these, we want to apply it in the case of Vietnam to investigate the extent of the damage caused by typhoons from 1992 to 2013. Keep in mind that what we obtain is a very reduced impact of typhoon, and it does not imply any underlying mechanism. So as mentioned, it is the nighttime light data is available at 1 kilometer resolution. The luminosity of the night light is aggregated to a measurement called digital number, DN, ranging from 0 to 63. We conduct the analysis for the mainland of Vietnam and sizable islands. There are over 400,000 pixels. and more than half are zero across the period of 92 to 2013. So this is the graph of the distribution of the luminosity, and we see over time with economic growth, the distribution shift to the right. However, a large share is still zero. Upon investigation, we see that they are mostly across the border in jungles and mountains with low level of human activities, and we exclude them from the analysis. And the nightlight data also correlates well with GDP. The changes in GDP can be explained by nightlight by 94%. And we found that if nightlight increased by 10%, GDP would increase by 6.3%. So on the typhoon side, we use a data set compiled from all the meteorological agency in the world, and we only use storms that reach typhoon strength, and we use the wind radius of 30 knots as the pathway of the typhoon. The wind radius measures the distance from the center of typhoon, and within this distance, you experience at least 30 knots of wind, which is around 55 kilometers per hour. So if you are inside this radius, you are affected. So here's a graphical illustration of a typhoon. We have observations every 6 hours, and if a pixel is in one of these circles, it is affected by the typhoon Doksuri. We have the statistics of the share of pixels affected by year. Some year when you have 11 typhoons near the coast of Vietnam, there are 80% pixels affected. In some year, 0. It gives us a good variation to estimate the impact of typhoons on Vietnam. So this is our model specification to measure how nightlight changes. We use the S variable. That is information about the storms affecting Vietnam, and a pixel-specific effect that capture special unchanged characteristics of that pixel. For example, it is if it is always more developed and brighter than other places, so this effect, this special effect will capture that. We have a year-specific effect that captures special characteristics of a year, but that apply to all the pixels. For example, every few years, they launch a new satellite, and this new technology can systematically increase the value of luminosity of all the pixels. And our economic crisis crippling the whole country, then this year's specific effects can capture that. Since our nightlight data, the majority is 0 for several years. We transform them using a function of inverse hyperbolic sin. It allows us to see the percentage change in nightlight, and unlike logarithm, it is identified as 0, and so we don't have to add 1 and artificially shift the whole distribution. So we first look at how the light of a pixel changes when it is affected in a given year, regardless of the number of typhoons, and it gives us a damage of around 9% of nightlight luminosity. However, on average, a pixel can be affected by multiple typhoons a year, which leads to the second column, where we see how the damage differentiate depending on how many storms that affect a pixel. We find a reduction of 4.5% for one typhoon on average. So to put it in perspective, we compile the annual loss of nightlife for the whole country, and it can be as much as 6% loss of economic activities. If we can trust the conversion we did earlier between nightlight luminosity and GDP, it means that on average, per year, we have 2.37% of GDP loss due to typhoon, and it translates into $1.8 billion of annual income because of the damage of typhoon. So this leads to our conclusion. So we see that typhoon is more than just immediate infrastructure damage and fatalities. It have a lingering effect. It can disrupt life. And this aspect is even more threatening, and the impact is potentially very large, as we have seen. And at the same time, the economy is growing very fast, and as well as the population, so it will increase significantly the damage. And with the human population continue to locate along the coast, so with future research implication, it would give us a better idea of how the impact of typhoons work. We have to incorporate both aspects, climate change, and at the same time, social and economic change, to understand what the future have for us. So thank you. That's the end of the presentation.
Thank you very much, Yen. I think this opens the floor to the discussion phase or questions phase. So please write down questions on the chat, as we are not using Zoom here, so you cannot speak. You can only ask questions. I forgot to mention, maybe also at the beginning of the presentation, that this work will be soon transformed into an IFD working paper. So most probably in the next few weeks. And using this satellite data imagery is also of interest more generally to IFD for its evaluation department. So it's both pure research and also useful in terms of how to use this kind of data to evaluate certain impacts and also the effectiveness of adaptation projects and things like that. So I'm still waiting for questions. So there is one coming from Hongdo. Hello. I saw several data products mentioned as a proxy for typhoons, but you only used IB tracks for your investigation. Is that correct, Yen?
Yes, it is correct, because after investigation, we see that these data first with the household VHLSS, the household survey done by the World Bank in Vietnam, we see that it is available every 2 years, and it doesn't give information on the number of events, and it only asks a household whether it has experienced an event during the last 3 years, and it does not give very accurate detail. And at the same time, you have the MDAT, International Database, International Disaster Database, and other research have shown that it has an endogeneity bias. So the richer the country is, the more likely the typhoon would be reported, and it is the opposite for Vietnam. So you have an under-inclusion of the event, and it can give very misleading conclusion of the overall picture. So with meteorological data, we have the exact location of the storm, and it is an objective measurement. without these bias.
And if I may, I think the other reason why we are not using EMDAT is also that the events that are also reported on EMDAT are events that were associated with high casualties, right? So an event is much more likely to be recorded by EMDAT if it was associated with a lot of damages. Whereas in our approach, what we really wanted was basically to have as much as possible the census of all the typhoon that happened, even though there might also be some typhoon that did not produce any economic damage attached to them. So that's why actually IB trucks was yeah, I mean it was the best data source that we could find as part of this study. But feel free to suggest any other data set that you think could have actually been used for this study, and we will be glad to look at it.
I see we have another one from Tanguyen. How do you account for omitted variable bias? For example, the more typhoon affected areas are often lagging in both level of development, human capital, and growth over time. These cannot be controlled for by your two fixed effects.
The idea of using a simple regression specification first is it is easier to deliver a message. And as it is interdisciplinary research, it can be easier to cooperate between different researchers in different fields. And the second thing is, so even if we want to include a lag specification, so we see what happened to the pixel this year if last year there was an impact. But then if you have a pixel that have been affected 11 years in a row in Vietnam, and is actually the case, then this current year is also affected by the previous year and also the previous year. So if we just include some lags, it will still be, there's some noise within these variables as well. And what we have is a very conservative measurement, and we try to keep the omitted variable bias with as low as possible by not including more bias. And it gives us the immediate impact. And also other research have shown that the impact does not last for more than 1 year.
I mean, to add to what Ian just said, I think I have to take issue with that comment. I mean, I don't really see what is the omitted variable bias that you have in mind, because we have to keep in mind here that an omitted variable bias is a variable that can affect typhoon and also affect other economic activities. And it will be quite difficult for me basically to think of a characteristic of a place that is going to affect the occurrence of typhoon itself. So I'm not really sure whether it is an omitted variable bias that you really have in mind, or if you can if you can elaborate a little bit more on what you mean by omitted variable bias, or at least if you have something particularly in mind, I will be glad to look particularly at the problem that you are pointing at. Otherwise, it seems to me that the fact that we are using a simple econometric strategy that is here a fixed effect. So basically, the idea is to compare a pixel, the value of a pixel when it is hit, to the value of a pixel on average when this pixel is not hit. So even though we might have some pixels that are much more likely to be exposed to typhoon, well, we are basically comparing the state of a pixel when it is hit to the state of a pixel when it is not hit. So it kind of takes into account the fact that different pixels have different exposure parameters, and the only variable, our measurement here is mostly focused on comparing the pixel on it with respect to itself when it is not hit. So it seems to me that it is a simple and elegant approach try to answer to that question. What is true here is that this approach doesn't take into account special spillovers. For instance, the fact that a pixel that is not hit, but that is neighboring a pixel that is hit, can still be affected. And in that case, I will completely agree with you that if we want to investigate the special spillover and also take into account the fact that pixels that are not hit might still be affected, we need a more detailed approach. But this is part of not robustness check, but part of analysis that we do in the discussion that we chose not to showcase here. So, I mean, and I can also see that there is another question by Hugo who is asking whether
a very mean
why
question.
why the analysis stopped in 2013. I mean, the main reason is because the satellite imageries that we are using, so the DMS-POLS satellite imageries, are only available for the period 1992 to 2013. There are also other satellite imageries available from 2013 to 2018, but they are provided by another satellite who has different characteristics. And actually, as part of a joint work that AFD is doing with the Colorado School of Mine, we are trying to create a much homogeneous data set from 1992 to 2018 that we hope we can use to extend the analysis to 2018. I hope it answers your question.
I guess it does. I see Hong typing, so let's wait maybe for one or two more questions. Yeah, I'm curious of what is the magnitude of the other two variables, years and locations, relative to typhoon occurrence in terms of modulating nighttime nightlight luminosity.
Well, I mean, we didn't really look at those variables because our question of interest is not really to provide an accurate model of nighttime light intensity, but it was basically to focus on the estimation of the impact of typhoon on changes of nighttime light. So we basically just focused on the effect of the dummy variable that it identifies when a pixel is hit, and the variable that identifies the number of typhoon that hit a particular pixel in a year. And the other thing that you also have to keep in mind here is that actually our approach is quite conservative on several approaches, or at least on several dimensions. One other dimension is that we say that when a pixel is hit, we see that on average, nighttime light intensity decreases by 9%. But actually, everything depends on which period of the year the pixel was hit. Assuming that a pixel is hit at the end of the year, we are still considering that this pixel is hit, even if there is no chance that a pixel that is hit at the end of the year will see the nighttime light intensity on that particular year decrease. Actually, the effect is much more likely to translate on the other year. So again, we really try to make our approach as simple as possible to convey the main approach that we use. And we think that actually our approach is underestimating the impact. But even by taking an approach that is underestimating the impact, we still find an effect that is quite high. So this also leads us to be much more mindful to the fact that if we were really to take into account all the compounded effect related to typhoon, it will be much higher than the 1.8 billion that we estimated. It's much higher. And this is just the economic, the macroeconomic impact. We are not actually including all the other human suffering and all of the other effects that previous studies have already documented.
Okay, thank you, Hongdo. maybe we wait for one more question from. Okay. Thank you, Tang. Interesting word there. Let me specify that, for example, many typhoon-affected places in central Vietnam are typically poor agriculture-dependent areas and tend to grow slower. In contrast, much of FDI into Vietnam self-select into typhoon-proof areas that have higher growth. So that relates to your previous question on the omitted variable bias.
Okay, it seems to me that this is not really an omitted variable bias. The way I understand this is that there is heterogeneity in the impact, and that some places will show a decrease that will be smaller than other places. And on that point, I think we are in sync with you. We think that the effect that we basically show is an average effect, and this effect is prone to vary depending on the place that is hit. And the other thing that I also want to really stress out here is that the measurement that we are using is nighttime light intensity, and it's presumably true that in agricultural places which are hit, we might underestimate the effect because some agricultural places are not going to emit a lot of nighttime light intensity. So nighttime light in that place might actually not be a true, a true counterpart of the amount of economic activities. So, and I completely agree with you on that. So behind this this number that we showed, there is probably a lot of heterogeneity depending on where the pixel is located, and it will certainly be useful to show how the effect varies depending on the place of Vietnam which is hit. And it is also true that we might be underestimating the impact on some places which are mostly agricultural places, because for those places in particular, nighttime light intensity is not the true counterpart of a level of economic activity. But this is really something that we have in mind. During the presentation, you will see that Yin has presented how the effect varies from one year to another. So this was basically the variation over time of the average effect. But it is completely true that we can also show how the effect varies depending on the place of Vietnam that is hit, and show where are the places that are much more likely to exhibit a high decrease in economic activity compared to others. So thanks a lot for your question.
Yeah, I think Tang's comment is somehow relevant, and we might want to discuss that further. Two more questions from Fong Cham Anh Le. The results are very interesting. I'd like to know the contribution of our research to the literature or to the policy makers. So again, you might want to answer this one, and then I will ask the one by Hugo.
So this is my personal opinion, and to see that the impact is potentially very large, and usually when we just look at the immediate loss by infrastructure cost and damage, it is really an underestimation. And even if there's a reconstruction effort, it's still loss welfare. It can serve as basis of mitigation strategy. And we have seen that recently there has been a very interesting case of, I believe it is Mexico or Brazil, that they use a natural disaster fund that is use index-based, which is based on satellite data index. And it is organized at the authority level, at the administrative level. So when there's an impact to a country, then they can insure against it and recover quicker from the aftermath.
Kenneth, you want to complement or?
Yes, I think that what you just said is completely true. I think we will share in the chat a link to a paper written by Alejandro Del Valle, Alain de Janvry, and Elisabeth Sadoulé, who are basically studying the impact of the Fonden. So Fonden is basically like an insurance scheme, a federal insurance scheme in Mexico that basically aims uh, at basically fasten the disbursement of funding so as to help municipalities that are affected by typhoon and natural disaster to start the reconstruction work, because one of the things that you see when a place is hit by typhoon or by natural disaster is that a lot of infrastructure are disrupted. And when those infrastructure are disrupted, it makes it really much more difficult to reach people who are in need. And what you really need in those places is really to disburse money so that those infrastructure can be rebuilt and help can go to people who really need those help, and also help strengthen the recovery of the places that are affected. And what basically this paper was really showing is that having this type of insurance scheme at the national level can really help um, uh, make faster the recovery and maybe alleviate suffering, and also help economic activity restart or help jumpstart the economic activity. So it can also, I mean, Etienne might actually say more about what we hope this work is can achieve, but it seems to us that providing a kind of macroeconomic estimating the macroeconomic cost of typhoon can really help show that there is a lot of economic activity loss, and that it can be possible to reduce the size of this loss by thinking about other type of policy responses. It can be an insurance scheme where part of the money, part of the reserve coming from exports in Vietnam is used to secure a fund that can be used for to help rebuild the places that are hit. But it can also be other type of schemes. And I know that there are schemes that are already available in Vietnam. But it seems to me that the other contribution that we also make to other papers is really just, I mean, it's actually that is by providing this measure of the macroeconomic loss. Other papers have focused on the effect on households, on the effect of the effect on firms, and here is really like providing this measure of the effect at the macroeconomic level. And the other thing that we also had in mind was, if it was possible to simulate the path of future typhoon, and because we also know the impacts of a typhoon, maybe we can also simulate the macroeconomic cost of future typhoon, especially future typhoon in a context where climate warming is, where the climate is warming up, and that even though we don't know whether the number of typhoon will necessarily increase, at least depending on the places which are hit, simulate the costs of future typhoon. Etienne, I think you wanted to say more about that part.
Yeah, just to complement about the contribution that, to our knowledge, this approach, this specific method has not been applied yet to Vietnam. And about the more policy oriented consequences, this research is part of a broader project which is called GEM Vietnam, where we aim at assessing the different types of socioeconomic impacts of climate change in Vietnam, as well as dealing with adaptation strategies. And we are currently building a report that should be published ahead of COP26, where part of these results will be present. And this work is really a joint collaboration between AFD and the Ministry of Environment. So that we really, it's really a topic of policy dialogue for us. I think also what Kenneth said in the end is very close to the question by Hugo on have you tried to simulate future impacts based on several climate change scenarios. I guess, Yen, you can say a few words about what has been done in other relevant literature and why we haven't done it yet.
So in relevant literature, generally they use a model that does not account for climate change. So they use randomly put typhoons around in the ocean and do a zigzag line with some algorithm behind machine learning that make it more typhoon-like, and see how the effects vary with economic development. And another one is with changes in the climate input, but without the socio-economic activity side. And another one has been done, but mostly for the US, that incorporate both climate change and human development. So what we have been investigated, we intend to apply is one of our co-author work using climate change scenario of RCP 4.5 and 8.5 and apply it to Vietnam, and at the same time using the shared socio-economic pathway with different projection of economic activities and population growth for Vietnam, and understand the future impacts better.
So to complement this, this will be dealt with in the working paper that you will be seeing soon on the AFD website in a few weeks from now. I don't see any other questions on the chat or on the questions. Kenneth or Yen, do you want to add anything? I see Tang is typing, so, but if there is no additional question, we might end here. Okay, there is one additional. I think this makes a great case on why governments need to invest in climate change adaptation in the typhoon affected areas. In Vietnamese, we have a saying, sorry for the accent, Song Chung Voi Le, living with the flood, and that's what the government is support through transfer policy. Clearly, this paper of views makes the case for more proactive support. Thanks for the paper, and thank you, Tang, for the comments. Very nice comment. And this will close our session today of IFD research conversations. Thank to all the participants. Thank you, Yen. Thank you, Kenneth. And see you soon in another research conversation of IFD. Goodbye.
Thank you, everyone. Goodbye.
Thanks, everyone.